In Chapter 5, we want to start looking at the area problem. The area problem is we would like to find the area under a curve between the curve and the x-axis. But how do we do that? Let's start with some basic areas. If we have a rectangle, the area of a rectangle is just base times the height. The area of a triangle, like this, is 1/2 base times height. And we can take a shape and cut it up into smaller pieces and look at the area of each of the pieces and add up the areas to get the total area. Okay, so those are some basics. So we're going to try to find the area under a curve. So let's say our curve is y equals x squared, and we want to go from 0 to 2 here to estimate this area. So how could we do it? We don't have a formula for the area of this curve. But what we could do is we could estimate the area of this curve using a formula that we know. So if I had just taken this and used one rectangle, that wouldn't be a very good estimate. But if I use one rectangle, I could use my base times height formula again. So what's our base of this rectangle? It would be 2. And what's the height? The height would be 4, because that's the y value here. 2 squared is 4. And this would definitely be an overestimate of the area, but it would be an estimate of the area using one rectangle. We decided to pick the right-hand side of this interval. If we had, so I'm going to put a subscript r here. If I had decided to use the left-hand side of the rectangle over here and made a rectangle like that, now the base is 2 and the height is 0. So, well, that looks like an underestimate of the true area. And I would say the area is somewhere between 8 and 0. The 8 overestimates by that, and the 0 underestimates by that. You could imagine that perhaps 4, the midpoint between those, or the average of those, would probably give us a better estimate of the true area. In this case, we used one rectangle to find our area. A better estimate would be if we had used 2 rectangles to find my area. So what if instead of n equals 1, we used n equals 2? So here, if we have our curve, now if we cut it into 2 pieces, so if I cut the x-axis into 2 pieces, I would have to go from 0 to 1 and then from 1 to 2. And we're looking at something like this. If I use the right-hand endpoints to make my rectangles, so my first right-hand endpoint would give me this rectangle. My next right-hand endpoint would give me that rectangle. And from above, we know that the area would be the sum of the smaller areas here. So the first one would be, starting from left to right, the base would be 1, the height would be, well, this height here is going to be a 1 there, 4 there. 1 times 1 gives us the first rectangle, and then base times height, 1 times 4, gives us the second rectangle. So if I add those up, I get an area of 5. It's again an overestimate because here it's above and above. We're overestimating. What if we had used left endpoints instead of right endpoints? So here, on my first interval from 0 to 1, the left endpoint is 0, 0. So there's my first rectangle. And then from 1 to 2, the left endpoint is 1, so here's my dot that I make, and there's my next rectangle. So base times height for the first one plus base times height for the second one, and I get an area of 1. We've got, again, an underestimate of the true area. Here, this part, and there, that part is being missed by using our left-hand endpoints. And you would imagine that the true area is probably somewhere between 5 and 1. If you want, you could average those two together to get a better estimate. What if we up this to n equals 4 rectangles? So now we have our three. Here's 1, there's 2. Here's our curve. There's 1, there's 4. Okay, so if we use right-hand endpoints from 0 to, oh wait, I guess we need to step back and say how wide are each of these rectangles. And I'm going to call each of these rectangles the base. I'm going to call it my delta x. That's the width of my rectangles. It's going to be, let's see, the whole interval is 2 minus 0, because we're going from 0 to 2, cut up into 4 parts. So each of these rectangles is going to be 1/2. So that's my base, 1/2. So base times height. Okay, there's my first rectangle. Since I'm using the right endpoints, there's my next one. Right endpoint, next one, right endpoint. And there we have, let's see if I could do that better. And there we have our 4 rectangles. So we've got base times height. Now what's the height? The height is 1/2 squared, right? Because our x value that we're at right here is 1/2, and we're substituting that into the function to get the y value, and that would give us a 1/2. Then base times height. What's the height of this next rectangle? Well, we would be at 1. 1 squared is 1. Okay, plus base times height. Our height now is going to be 3/2 squared, and then base times height is going to be a 2 squared there. So what I'm doing here is I'm just delta x is my base for each one of these, and then this is f for the y value at whatever x we're at. So if we are using left-hand endpoints, my x values are 1/2, 1, 3/2, and 4/2, or 2. Should probably use a different color there. Here, let's try a different color. There we go. So 1/2, 1, 3/2, and 2. For the, oh, I guess we should add that up. If we add that up, notice that there's a common factor of 1/2 in all of those. So then I've got 1/4 plus 1 plus 9/4 plus 4. So what is that? 1/2 times 10 quarters, 5 plus 10 quarters, or 5 halves. 5 is 10 halves, 15 halves. 15 halves times a half is 15 quarters. Alright, so now using the left-hand endpoints. So now I'm going to have an underestimate because when I make my left-hand endpoints, notice all of my rectangles are below the curve for these. The base of each of these is 1/2, and the heights are just the y values at the left endpoints. So when x is 0, we have 0 squared plus 1/2 squared plus 1 squared plus 3 halves squared. What I'd like to point out is this and this look the same. The only difference, when you think about it, will be the first and the last rectangles of this process because of the way we're picking either right-hand endpoints gives us that tall one, or the left-hand endpoints gives us that small one. All the others are the same. So what is this area? This area is 1/2 times, we got a quarter plus 1 plus 9 quarters. That's 10 quarters there. 1/2. 10 quarters is 5 halves plus 1 is another 2 halves. That's 7 halves times a half is 7/4. And you would expect the true area to be somewhere between those two. What we'd like to do is we'd like to be able to get more rectangles. More rectangles means less error. Notice the distance between these values, 15/4 and 7/4, is kind of closing in. Over here, where we had 8 and 5, that's a bigger difference. Sorry, 8 and 0 was a bigger difference. Over here, 5 and 1, bigger difference. Little bit smaller difference, even smaller difference. So it would be great if the left-hand sum and the right-hand sum would give us the same value. So what we would really like is we would like to have n approach infinity.